Happy to see you all, and I'm really happy to be here. And now we will try to share some knowledge with each other. But I will start with a brief introduction of what 84 Codes are doing, followed by an agenda of the evening, and then we kick off with the lightning talks. On a beautiful day, you might go out for a run, and you might be using a workout application. Do we have any runners in here? I know we have some. Nice. Afterwards, when you have completed this running session, you might look at the leaderboard, new personal records, or maybe the track that you have been running. The IT architecture of Adidas training app, Runtastic, is divided into many different parts, microservices, where one part is responsible for the running session, one for the leaderboard, and one for the map functionality, and so on. In order to be able to handle millions of users at the same time, many of these microservices communicate through a queue, a message queue, and in this case, through RabbitMQ. So what does 84 Codes do then? Well, we provide and simplify the operation of running RabbitMQ servers in the cloud. So instead of your company setting up your own tech team or your own RabbitMQ solution, you could use our software as a service called CloudAMQP, which has everything included already. And RabbitMQ simplifies the scaling when your business is growing. It prevents websites and application from becoming overloaded or crash as a result. And when Corona came, there was a big increase of numbers of users running and exercising, and the number of users for Adidas training app also increased a lot due to this. But thankfully, their IT architecture made it really smooth with this increase of users. Other customers we have is one of the world's largest brewery. It's also a newspaper in the United States, which has more than 65 million readers a month, and one of Sweden's largest payment provider, and also several of the world's most famous car brands. So it's really a fun company to work at. During the last 3 years, we have also had a project going on. We have built our own message broker called LavinMQ. It's written in Crystal, which is a language quite similar to Ruby. And we're happy to say that it will be released as version 1.0 really soon. So it's something to check out.
So I want to start with a story. Yeah, we don't have the speaker notes, but that's okay. It happened about 2 years ago. So my Sambo, who's here as a teacher, she was tired of the school setting, and she really wanted to change careers. So she wanted to become a developer, and she asked me, "Hey, Yusuf, what language should I learn?" And so I really wanted to say, go learn Ruby, but I wanted to do a little bit of research before that. So I went on the LinkedIn job boards. There's not a lot of Ruby jobs. I went on, so she wanted maybe to go to a boot camp. So I went to all the boot camps in Stockholm that taught programming. And there's no boot camp in Ruby in Stockholm. So I was like very sad, and I was like, you should learn JavaScript. So that made me frustrated, a bit sad and angry, because I couldn't, this is like someone who I loved, and I couldn't welcome her into my job community. So, hi, my name is Yusuf, and welcome to my therapy session. So let's start with the symptoms, all the things I saw. So there are not many entry-level jobs in the Ruby world in Stockholm today. Everyone is looking for seniors or at least mid-levels. And at the same time, there are not a lot of junior Ruby developers to fill those jobs that don't exist. So it's a catch-22 kind of thing. And there's even one more thing that I wanted to think. There's like a There's a platform called First Ruby Friend, where people can sign up to be mentors to Ruby juniors. And I signed up for that a year ago or something. And the only thing I got was, we have too many mentors and not enough mentees, so we can't match you with anyone. So even that, when people are trying to get more juniors or like to form them, it's not working. But I wanted to dig a little bit deeper. So what are the causes for this? And the cause is that Ruby is now a mature language and not dead. It's missing all the pathways that newcomers are usually taking to enter a new programming language. So it's not taught at universities because Python won that game. It's not the hype thing anymore because JavaScript won that. And it's not big enough for the enterprise market where there's companies that are big enough to just pay people for 6 months to learn, like Java or .NET. So what do we have as effects of this? The effects are that the community gets smaller. We have less people entering to fill out the gaps by the people who naturally leave the community. It's getting harder to hire. As I know, like a lot of you have tried to hire people, and it's actually pretty hard now. And one thing that I was acutely aware when my Sambo was struggling with async and the wait is that newcomers miss out on the joy of writing code that is nice and easy to write. So I'm telling you that, but why should I care? Why should we care? So what's in it for us? We want to keep the community healthy and alive. We want to, for example, we want to have people to care for our gems or to go speak at conferences. We want to hire the motivated developers because if you've ever seen juniors, they lack experience, but they're very motivated and they make up for it. And we also want to learn to become better teachers and mentors. And this is a skill that's really hard to practice if you don't have anyone to practice it on. So that's also a thing that I learned a lot from going through that experience. This is a blog post I wrote, which is the one that had like the most views on my blog so far. And it's just a brain dump of the things that I had to tell my Sambo over and over again. Other things that are in it for us. We want to increase diversity in the community. If you look at how this room is composed of, like a lot of juniors come, okay, there's like the new graduates that you don't really control for, but there's also a lot of people that switch careers, that want to try something else. And this is a way for us to both increase the diversity and also get an external view on our industry by having someone who has previous experience in some other field that can bring their experience. They don't know programming, but they know a lot of other things that they can bring and more. But why us? Why should we make efforts as Ruby developers? I think we are in a unique position to be a very good match for these newcomers. We have this focus on the developer happiness, which is something that is missing from a lot of languages. And I've seen a lot of people going through a boot camp, getting really crazy with like all the complexities that shouldn't be there, and then just drop out. We are also, as a community, as the Ruby community, we are a welcoming community. We have this saying, minus one, which Mats is nice, and so we are nice. So we're nice to people. It's a core part of who we are. And the last part is that we are trying to fight the complexity that the modern web has become by going back to, okay, we go to HTML, we just do the simple things. And I still remember, like on the first day of my Sambo's bootcamp, they were like, okay, so the web works, there is a back end and a front end, and those are completely separate. I'm like, no, this is not how it is. And this is something that if you do Rails, it's very apparent. But if you're in another stack that separates these things, then you get in this level of complexity that doesn't need to be there. So these are the problems that we have. How can we fix this? So maybe one of the solutions, like the solution, I don't know if I have the answer to everything, but if you have an opening at your company, if you need someone to fill your ranks, consider opening for junior positions, and consider opening for in teams where they have the bandwidth to give these newcomers proper support. And also consider organizing some events that can help other people come in this industry. Like we used to have Rails Girls, or we have also Rails Bridge. So it takes effort, but it's worth it. Think of the fact that you're helping people enter the industry. We've all been here, been juniors at some point. We've all had someone take a chance on us. The person who took a chance on me 8 years ago is here today. Thank you, Jens. So do it, try to do it to become a better teacher, do it to become a better member of the community, and do it because it takes effort, but it's worth it. Thank you.
Today, I want to talk a little bit, like a short story, about how we improved performance of some of our GraphQL requests using Elasticsearch and a GraphQL feature called Look Ahead. We have a fairly classic API-only Ruby on Rails stack with GraphQL API, with some legacy REST endpoints, relational database, Elasticsearch, which for those of you who don't know, it's like a search and indexing engine, and a bunch of other stuff that are not really important for that. So a few years ago, we did this slow transition from REST API to GraphQL, because we have a lot of different clients. We have Android apps, we have iOS apps, we have web clients, admin tools, and it really made sense to give clients more flexibility of what they are fetching. And I will mostly talk today about our main resource that we handle, which is catches. Basically, whenever someone catches a fish, it's a catch. And we have quite a lot of them, like 15, 16 million. And they were exposed from different contexts. You could fetch them by user, by species, by some map area. And we had different controllers for them. Some of them used Elasticsearch, which made it faster to fetch. For example, geolocation searches were much faster in that engine than in relational database. When we moved to GraphQL, we decided to have a universal set of filters that you can apply on this resource. So basically have one GraphQL type that can be accessible from any nested resource, like from top level catches. You can fetch it from the user, catches, and you can always apply the same set of filters, which was great. It gave a lot of flexibility to the clients. We could implement a lot of nice features in different platforms, but there were some drawbacks. We saw performance dropped in some of our requests really considerably. And we started investigating why is that. So we identified two main issues. First one was expensive aggregations. So after we apply all those filters, and you want to fetch some aggregations that require a lot of joins, a lot of group bys. Before, we had that exposed as a separate endpoint, and it was using very optimized Elasticsearch query. But we don't support all the filters in Elasticsearch. And that was a huge performance hit, because we were doing all of that in Active Record. Another issue that we identified was filtering on these expensive filters, like geospatial filtering, that previously was always done in Elasticsearch with limited set of filters. But right now, we gave this flexibility to fetch with any set of filters. And it was just slower, much slower with relational database queries. So we couldn't move everything to Elasticsearch because we can't just dump everything into the index, all the associations and all the filters that we support. It was just not a viable solution. So we thought that it might be good to dynamically decide whether to use Elasticsearch or Active Record based on the filters that were applied and based on the fields that were requested by the clients. So welcome Look Ahead, which is a GraphQL feature, GraphQL mechanism that is available in some of the GraphQL server implementations, including GraphQL Ruby. And it basically allows you to navigate and to explore the whole query as like an object. So you can see which fields are selected. You can go to a parent, to child, and basically have a full picture of what is requested by the client. To use it, it's very easy. You just pass a look ahead symbol to the extras when you define the field, and GraphQL Ruby will inject that object to your resolver. And you can basically check, okay, is the user selecting top species field, and you can act accordingly. You can select if all the fields that are requested is just an ID. Maybe you can use some cached value. It's also, you can check arguments, so filters that are used. You can check parent. It's also very commonly used to avoid n+1 queries. So you check which associations will be fetched down the line, and you can preload them. So let's look at like few very simplified examples how we use that. First example is this expensive aggregation. When we get that, we check if the filters that are requested are supported by our Elasticsearch index. And if there is a match, we can just happily use much faster Elasticsearch implementation. If there is not, we'll just fall back to a slower Active Record. And that's another example. When we fetch a list of catches, we check if the filters are those expensive filters that are better calculated and faster on Elasticsearch. And using this look ahead object, we select which exact fields are requested, like ID, name, maybe some other nested associations, and we check if we support them in our Elasticsearch index. If there is a match, we use Elasticsearch, otherwise we fall back to Active Record. And yeah, nothing better than seeing this latency drop after release. Of course, it's not the perfect solution. You can still, client can request some unusual set of filters and fields that will still be slow. But it was a very low hanging fruit for us, and it improved like 95% of cases. So we happily accept that solution and accept that not everything needs to be super fast, super smooth, but it's when it's fast in majority of cases, then it's good for us and it's better for users.
Note about me making websites since 1995. I was 12 years old back then. And my friend had a 2400 baud modem, and we had a good time making websites. First gem install at version 0. something, working full stack with Rails since 2007. I basically fell in love and never fell out of love with Ruby. Last 8 years at my news desk and currently DevOps lead, though I want to emphasize that I'm a Rails developer. I'm not like a DevOps guy. I think of DevOps as maybe the original meaning of the thing, which is like, you know, you're a developer and you're doing ops because maybe you have to or you want to. I'm Debakis on Twitter if you want to follow me there. So the agenda here is motivation for in-house platform. So we're going to talk about in-house Kubernetes platform that we built at my news desk during the past 6 months, me and Fredrik up there. So the motivations, proof of concept phase, viability study phase, platform components and choices, the developer experience, and some final words. So we start with the motivations here. So the main thing here is actually GDPR issues. So with non-EU based hosting providers. So the light interpretation of GDPR is that data should be stored within the EU and you can use kind of any hosting provider. But a stricter interpretation is that you cannot actually have data controlled by any like non-EU company, because the government of the US, for example, they might just say like, hey, give us this data, whether it's in the EU or in the US. So, which rules out all the big cloud providers, etc. And then we have been on Heroku, so we felt that Heroku has entered severe stagnation and increasing number of security stability issues over the last years. And finally, cost, which isn't really so much a motivation as an enabler of what we're doing here. So alternatives we looked at is, the first thing that came to mind is like, okay, let's find a Heroku clone in the EU. We don't have like, a full ops team at my newsdesk. It's more like we just have some people who have more of a DevOps leaning, but we want to empower the developers. So Heroku was a good fit for that. And we looked at some alternatives, but the UX seemed to be a bit mixed, and also trust issues. These are mostly upstarts. They are not so well known. Can we really trust them with our business? And then this idea then of do-it-yourself Kubernetes. And I first got this idea, I think, late August last year, from a post from a Finnish Rails developer, Vito Botta. He mentioned he had made a script or like a CLI tool for bootstrapping Kubernetes on Hetzner Cloud. And he was, at a kind of a medium-sized company. He wasn't at a big enterprise. So I thought like, okay, maybe this is viable for small, medium-sized companies as well. And also this Hetzner thing looked quite incredible from a pricing point of view. So the hypothesis here became that the pros would be of Kubernetes like trending to become the de facto deployment platform, certainly like outside of cloud, but even inside cloud, a lot of people are now using Kubernetes. And also that open source operators would be available for managing high availability of databases. This is something that we don't really want to have all the expertise, but if we have software that can do that for us, that would be cool. And to give an example, like Heroku Postgres, which is the biggest Postgres provider in the world, they managed like multiple millions of clusters with 9 people. So the secret is actually in the software. It's not, you don't need a lot of people if you have good software. And then freedom, hosting agnostic. Move anywhere, do whatever you like. No vendor lock-in. You don't feel like you're being taken hostage by Bezos or something. And a stronger end game. We can customize and optimize things to our needs. The cons would be like steep learning curve, having to build the tooling in-house, platform engineering, which I learned was like a big term within the sort of Kubernetes world, and also unknown unknowns, like what are the things we don't know. So we have to have a bit of courage also to go for this. And so I was feeling like maybe this is a good idea, but it's dangerous to go alone. So I knew, and I'm not like a Kubernetes guy, but I knew I had a colleague, Fredrik, up there, who was actually kind of into Kubernetes. So I thought, why not ask him if he's like interested in this thing? And he was like, yeah, let's do it. And then we got CTO Daniel, who was also up there. He was like, yeah, this sounds like could be fun. So, okay, let's try. But I went into like my own proof of concept thing. At my newsdesk, we have lab days, which I describe as do whatever you feel like doing for 5 days per quarter. It's not maybe the official description of this, but that's how I feel about it. So during this lab week in, I guess, early September, I wanted to try Kubernetes. And this was also the time when Heroku had just announced that they were removing the free tier. So I had some hobby apps, and I thought, why don't I try running my hobby apps on my own little thing at home? So I went to Blockit, and I found a second-hand Intel NUC, and I haggled a bit, and I got it. And then I tried putting Kubernetes on there. So this is, I guess, the summary of my week with Kubernetes. It went fairly well. Like I could bootstrap a K3s. There's a kind of a minimal Kubernetes distribution. I found out about Cloudflare tunnels, which was a really cool way of doing the ingress, like how to expose my web service to the internet. You don't have to open any ports in your router, etc. That was cool. I migrated my hobby Rails projects Ragtime. Also from sprockets to prop shafts. So I did some simplification of the build process so it would be easier to make the Docker file. And then I learned about making Docker files. I'm not a Docker fan, have not been, but I had to learn it, so I did. And then figured out how to deploy Postgres via the crunchy Postgres operator. And finally deploying this app, exposing it with the Cloudflare tunnel, getting metrics with Prometheus, log with aggregation with Loki, and finally how to deploy this and maintain it using GitOps via Argo CD. So this was like, weak proof of concept. Okay, seems to work. So we got this. But then, okay, we have to get serious. We have to run our application, which is significantly more complicated, of course. For those who don't know, MyNewsDesk is fairly old software as a service. We have our code base, I guess, is like 17 years old. It's basically as old as Rails itself. So there's a lot of stuff in there. Like, can we run MyNewsDesk? Next phase. And now it's like me and Fredrik, we're hacking along on this. So we're selecting Talos Linux as the operative system. This is a minimal operative system just for running Kubernetes. We bootstrap this on Hetzner Cloud. So we're not on bare metal right now, but we're doing it in the cloud so we can easily kind of throw away nodes when we need to and try again. We got metrics and log aggregation up and running. We tested something like 8 database operators, and we learned to distrust high availability of Redis along the way. Like, when I set out to do this, I didn't expect Redis to be like the biggest headache, but it's really been the biggest headache. Like, Postgres, no problem. Elasticsearch, no problem, but Redis, problems. Made an optimized multi-platform Docker image, because at this point we also weren't sure if we would go with ARM or AMD 64 as the architecture. Hetzner had some really cool 80-core ARM monster server that we thought, well, hey, that would be cool. But yeah, it turned out that ARM wasn't really there for Kubernetes, some of the components that we wanted to use, so couldn't really go there, which was probably good anyway, because you don't really want monster service in Kubernetes. It gets rough when you need to reboot. And then we struggled with Argo, this GitOps tool, quite a bit, which is maybe also because we were learning Kubernetes at the time. We got a lot of errors every day that we had to figure out what it was about. And we imported our production database many times over. We researched 8 persistent storage solutions, tested 3, settled on 1. And we got MyNewsDesk running, but with very awkward performance in the cloud. So that's when we decided to just, okay, let's just order a bunch of like bare metal servers and try there. And also we connected these nodes on the VLAN, networking, like my biggest nightmare. But we got it working. So by week 6, we had this running on bare metal. And now comes some numbers, which was highly requested. So here we're kind of pitting 8 performance LDynos with Heroku Postgres Premium 5 and some other sort of high-tier databases against 2 AX1-on-1 servers for web and 2 for databases. So each of these servers, they run AMD 5950X processors. That's 16 cores, 32 threads. 128 gigabytes of RAM, and they also gave us 7 terabytes of NVMe that we don't know what to do with per server. So first, then latency. This is, we're doing our newsrooms. So MyNewsDesk is a PR platform. All our customers get their own little newsroom. And we're benchmarking like the MyNewsDesk newsroom on this server. And we can see quite clearly here already that like the Heroku average latency here is like 200 milliseconds, while we get 134 on the bare metal. So looks great here already, and especially when looking at like these high percentiles, it's a massive difference. It's like 3x higher on Heroku. Throughput, same endpoint, but now with 64 concurrent connections. We get requests per second on Heroku, 163, and 261 on Hetzner. And again, we see this huge discrepancy on the high percentiles, like 1.6 seconds on Heroku. We also did a sustained load test where we took from our log entries, our log aggregation at the time, we took the last 7 days of GET requests, and then we replayed them against our test cluster with 96 concurrent connections. We left it running overnight with full load. And we could then see on New Relic, we reached 28,000 requests per minute. That's about 460 requests per second. And we were now at 10x our normal production load. So this is pretty good. And 160 millisecond average latency. That's maybe in line with the latency that we would see on average on Heroku. Though without this load on Hetzner, then the latency goes down. And we could also see that Postgres is actually the bottleneck now. It doesn't matter if we throw more web servers on it. It's just going to be bottlenecked by Postgres. So the cost then, in this particular comparison, we have Heroku on the left at 7,650 per month, Hetzner at 520. So that's interesting. So yeah, viable. Now, this section is going through all the little components and choices that we had to make along the way. That's to give you a feeling of what we actually spent these, not fully the 6 months doing, but there's a lot of sort of testing out different approaches and different things to choose the right components to build up this platform. Some of the slides might be a bit like what's going on if you don't have no clue about Kubernetes, but I think if my hope is that some of you might actually try this yourselves after this, so you might then go back and reference this and be like, now I know what he's talking about. But okay, first off, hosting provider, we already mentioned Hetzner. Why? Very simple, price performance, it's the best. So can we back that up? Yes, we can. So I've been making this spreadsheet. This is public, you can look at it if you want. But basically, I figured that we have to performance normalize the cost of stuff. So I did benchmarking on all kinds of providers and servers and things. And just to give some example, then here's the price performance column. If you look at Heroku, 91 euro per performance. And if we look at what we are going with on Hetzner, we have 2.37. So it's something 50 times more expensive to get performance on Heroku. That's food for thought. Then the OS, like I mentioned, we went with something called Talus Linux. It's a minimum OS tailor-made for running Kubernetes. So the pros, it runs Kubernetes. That's what we want to do. It's super minimal. So it's also very secure, it doesn't expose anything. You cannot shell into this OS. You cannot install packages. The OS is on a read-only partition, so it's basically an immutable OS, and it just runs Kubernetes. So quite interesting. And so in my head, this is okay, I don't have to SSH into some Ubuntu thing, and it tells me I have 100 packages I need to update, and what happens when I update it, I don't know. So that was nice. They have an exceptional community Slack, and configuration management is quite interesting because it's just a YAML file. So it's declarative, it's patchable and stageable. So also when you're trying out new config, you can also just tell it to try it out for 5 minutes and then roll back, which was handy when I was doing networking because I would lock myself out of the nodes, and that could get dicey. Also, it's zero headache Kubernetes upgrades. This is a concern that many people have raised to me when I tell them oh, we're running Kubernetes. Oh my God, what about upgrades? I don't know how it is to upgrade Kubernetes on other platforms. We basically only did it with Talos, but we run a command, it does the whole thing, it's done in 10 minutes, there's no downtime on anything. Great experience. The cons then, it's another learning curve. It feels weird to not have a shell. And we had to learn new ways of understanding and interacting with the OS. It's fairly early days, it's not widely adopted, and it may not support all the use cases. For example, we might have preferred having SRAID for more security on our disks, but that's not supported. So some alternatives considered, managed Kubernetes, it seemed a bit lame. We couldn't do it on Hetzner. So. Rancher OS is also an OS for Kubernetes, but it's made by Rancher, who were acquired by SUSE, and when a company gets acquired by a big company, that's not a good sign. So all their cool projects, they had really cool projects actually, and they had a really kind of you can sense that they have a knack for trying to make things simple, but they're all kind of abandonware now, it feels like. And then Ubuntu K3s would have probably been the thing we did if we didn't do Talos. Kubernetes resource management. So inside Kubernetes, everything that's in there that you run, it's a resource. There are different kinds of resources. You can manage them by just like using the CLI tool and applying things. But we wanted to use GitOps or infrastructure as code to make things more manageable and reproducible and to understand what we're actually doing, because we don't really know Kubernetes yet, especially. So it seemed mandatory. And Argo CD is the most popular GitOps alternative by far for Kubernetes. It also provides a decent web UI. It does have cons. There are like 2,000 open GitHub issues. It wasn't very intuitive sometimes when we would hit these error states. Again, that's also partly because we didn't know Kubernetes very well. The UI might not always be in sync with the backend. Sometimes we have to reload to actually see the current state. You end up with 3 layers of truth, like what's in your Git repo, what Argo has picked up from the Git repo, and what is actually in Kubernetes. So the idea here is that Argo should be the source of truth, but in reality you might have some drift, or you might need to pay attention. Helm is like a package manager for Kubernetes, so it's supported in Argo CD, but we also hit some edge cases where it didn't behave the way we thought it would when we were installing packages. It requires some extra config to install large resources, which we had to do with some of the operators. And to begin with, we thought that we would use self-heal, which is like trying then to reconcile. So if Argo is the source of truth, and then you make a change directly against the Kubernetes resources using the CLI or something, then Argo would be like, hey, this shouldn't have been changed, and it would kind of overwrite it again. But then we would also run these operators which run inside Kubernetes, which might have another idea of how things should look, and then they would start to fight. And they would just get into this endless loop of like changing back and forth. And we still don't know much about etcd. But the thing that happens in etcd, the database, is that whenever you change one of these YAML files, it actually makes a copy of it. It's like, and it keeps the revision. So in a matter of minutes, you could have like gigabytes of stuff going on there. So that was interesting to get to know that. So we turned off self-heal. Alternatives like ditching GitOps, maybe, but probably I think it's the right idea to use it. FluxCD is another GitOps alternative, but it's not as widely used, and it's maybe not as user-friendly. Network interface. We just went with the default one in Talos. It's simple. It's a default of many Kubernetes distributions. A con here is that it required us to be a bit explicit. Like we had to patch our nodes. A node is a server in Kubernetes language. So we had to annotate that with some private IPs to avoid the nodes using the public IPs for communication. And if they used the public IPs, sometimes they could not communicate because of something about the Hetzner network, which I'm not a network guy. I don't know why, but that's the case. And it's also not as flexible or scalable as some of the alternatives, but we don't really have the need for those things. Alternatives could be Calico. It was suggested in the Talos Slack by the Talos developers. Kubespan is not really a network interface plugin, I think, but it's a really cool thing that Talos also has in their software, which is kind of a virtual network where you can bring in nodes from any other cloud service or Metal. You can like mix and match, and it kind of pretends to be a cohesive network together. So that seemed quite cool. Our current approach only supports bare metal nodes within Hetzner, so we cannot like make a hybrid right now. We tried a little bit, but I couldn't make it work, so kind of bailed. But it would have been interesting to have that ability. Then you need to build your Docker images. We just used the CI we already used, that's Buildkite, which made it quite simple. We considered Docker Hub and GitHub Actions, but that would have been slower, and it's important to be fast, so we just went with Buildkite. For the registry, we went with Google Artifact Registry. They have the most straightforward pricing. You just pay for the storage and the network. Whereas, for example, AWS, they like to quadruple the price of S3 for the storage. And you can kind of, if you read between the lines, you know you're getting scammed, right? So it was also the closest region to the Hessner data center, which is in Helsinki, Finland. The cons, it's a bit ugly, the URI prefix, so nothing major there. We did consider Docker Hub. It had some weird pricing. GitHub container registry we used for a while, but it was really slow sometimes, probably because the origin was in the US. And if you get a bad network across the Atlantic, then suddenly it would take a long time. And we tried also some other things, like self-hosting seemed risky. Storage class, this is a big deal in Kubernetes. So I want to start here by sort of describing the two major things you can do with storage in Kubernetes. You can go for local storage or network storage. So in the local storage approach, you have your nodes, that's your servers, and you have your pods, which is like the workloads. So here we pretend we have a Postgres with 2 replicas, and they have their storage and they're on the node. It's just like a path on your hard drive on the host. Very simple to understand. The networked approach is where you have your nodes and you have your pods running on them, but all the storage will be on separate dedicated storage nodes, or they could be on these other nodes as well. But the idea is that they're decoupled. You're decoupling storage and compute. So then what happens if node 1 dies? If you have the network thing, then Kubernetes will be able to just reschedule the compute on another node. But in this case, that's not possible because there is a dependency here. So that's the kind of thing that you have to think about. Of course, there are pros and cons with these. We chose to go for a local storage approach. It was the simplest thing we could do. It's something that we could understand. Reasoning about this network storage seemed very tricky. And also there's an ocean of alternatives, so it would have taken, you could spend months just figuring out which kind of network storage to go for, I think. It has a long name, OpenEBS Dynamic Local PV Provisioner, that's what we use, and it has a donkey thing going on there. So persistent volume is a pass on disk, very easy to understand. There's no performance overhead, which is also nice. If you ask Kubernetes guys what you should do, they're network storage. If you ask Postgres guys, they're local storage because you want your transaction speed. So we felt that we could still be cool and use local storage. All right, let me just skip through it. This is just to give you an idea. There's a lot of alternatives here. Some of them are commercial. Some of them are extremely expensive and probably really good. But we're not in this to pay people because we're reclaiming the stack, right? Secrets management. This is, if you're on Heroku, you have your environments. We went here with Bitnami sealed secrets, which is just in the GitOps repo, the secrets are there. They're just YAML, but they're encrypted. And the keys are inside the Kubernetes cluster. So it's only the cluster can read the keys, or the secrets is the idea. So it works well with GitOps. It's simple to comprehend, and there's no dependency on external services. So you can't share the secrets across clusters because there is this the keys should only belong to one cluster. Changing a single part of a secret rewrites the whole thing because of encryption. So you can't really blame and figure out when a certain environment variable changes necessarily. And it requires some tooling. It's very time consuming to work with manually because you have to decrypt and encrypt, and it's just, this is what it looks like. This is our main monolith, kind of a snippet of the thing. So you have your environment variables, but they're encrypted. Alternatives considered, we talked yeah, this is the real deal. You can try to decrypt if you want. They're also cut off here. So, but alternative considered HashiCorp, if we use something like this in the organization, maybe this would have been a go-to thing. Or if you use some other secrets management already, you might want to use that. But for us, we didn't have anything like that, so it seemed very simple to just keep it in Git. Ingress. Ingress is the thing that exposes your web servers inside Kubernetes to the outside internet. So typically you have something like Nginx or Traffic or something which listens on port 80 or 443 and it takes care of routing within the cluster. But we went for Cloudflare that I also mentioned before, which is an encrypted tunnel between Kubernetes and Cloudflare. Pros, you don't have to open ports, simple to use in bare metal environments where you might not have access to load balancers and elastic IPs and all these things. No need for certificate managers because you're just encrypted into the thing, and the SSL part is on the edge. And it's great for home networks because you don't need to fiddle with your router settings. The cons is you have to be okay with marrying Cloudflare. So this is maybe the only part where I deviate a little bit from this reclaim the stack. So I'm sorry about that, but for us it was worth it. We might want to attack the edge sometime, but maybe not to start with. So we're happy to keep using Cloudflare, which we already use. Also, Cloudflare is not really like a Kubernetes native thing, so it doesn't hook into like Ingress or API Gateway, which are resource types within Kubernetes. It's not a big deal. We also found that the points of presence of Cloudflare, they don't really load balance if you run multiple Cloudflare daemons in your cluster. Also not a big deal because they're not CPU heavy, they're just like little proxies, so it doesn't really matter. But you can run many for high availability. Service mesh, like what is a service mesh? What are we talking about? Service mesh can do many things, but it's like kind of some steroids on your network or like HTTP traffic within the cluster. So what we saw was not only that the points of presence would kind of send imbalanced traffic down to the Cloudflare, but also that due to just some quirks in the Kubernetes network services, we would end up seeing like maybe 60% of requests going to a single Rails application server and maybe 20/20 for others, something like that. And that's not great then because Rails actually uses CPU, so we want to have a good balancing if we can. And that's where we can put this service mesh inside, and that becomes like more intelligent, more aware of what's going on, and it can intelligently distribute. It's actually even more intelligent than like just 30/30/30. If it notices that on average one node is slower, like maybe there is some performance degradation, it will actually use that like a moving average to figure out where to send more traffic. So we used Linkerd, well used, well documented, relatively lightweight. It load balances in the cluster HTTP requests very nicely. And it also has a great real-time dashboard for observability. The cons is it was a bit annoying to install via Argo CD. We had to go through some certificate hell, which is something that you learn in Kubernetes to hate quite severely, certificates all the time. And highly intrusive. Like it will inject into your running pods, it injects a sidecar container, which is the Linkerd proxy. So it's kind of like monkey patching. It's like you think you're putting your pod there, but actually it gets like mutated before it boots. So suddenly it has another thing inside. And the worst thing that happened to us, it broke some TCP communication. When we were communicating with SendGrid SMTP API, suddenly it just didn't work anymore because Linkerd was trying to do something with the packets or something. So you can run into things, and you have to configure it then if you run into things. Alternatives could have been Nginx mesh or traffic mesh if we used one of those ingresses maybe. Istio is another popular one, but it's like more complicated, etc. So we don't need complexity if we don't need it. Monitoring, Kube, Prometheus stack. This is pretty much like a de facto standard. Everyone uses Prometheus, and this stack is kind of a ready-made thing. You just put it in your cluster and you get a lot of metrics for everything. But cons is like there's a lot of components in there. We don't really know what's in there. We haven't looked at it deeply, but it seems to work, so maybe that's good enough. Alternatives considered could have been like making our own Prometheus stack just to understand better what's going on, but with the time constraints, probably not worth it. Corinne is an interesting data store. It's built on top of ClickHouse, so it's a more performant option. I would be interested in like trying this out sometime. Then log aggregation is another fairly standardized approach to use Grafana Loki. Very easy to get going, very popular, just works. A cool thing is that it supports decoupled S3-based storage layer. So you don't have to then worry about like in-cluster storage. It uses like an in-storage cluster storage for like hot data. And then you can have your cold data on S3. So now we don't have to worry about like retention anymore of our logs, which is cool. Like if you buy a service, probably you have like 30 days or something. But now we don't have those constraints. We would use like 1 year for GDPR reasons maybe. The cons, they have some default query limitations. We haven't figured out or looked at like how to optimize those yet. Sometimes the queries are slow, because it's a bit of a black box again, like we haven't figured out like why. But generally the queries are much faster than they ever were with like log entries, the service we use. So it's still better than what we had. The UI is probably the worst, maybe, log UI I've seen. So that could be better, I guess, but it's quite powerful. You can make powerful queries, but not as simply as you did in like log as a service things in the past. Again, you could put CRIN as a data store here, which could be interesting. Now we're on to operators, starting with Postgres. We chose here the crunchy Postgres operator, PGO. Pros, highly trusted. It's founded by some of the people who built Heroku Postgres. That is Crunchy Data, the company. And they also contribute, I think at least they claim to contribute something like 30% of like the code that goes on in Postgres. It enforces backups, which is mostly a good thing. Sometimes it maybe like you just want to put like a staging cluster and you don't care, but you have to back up. But that stuff ends up automated anyway, so it's not that annoying. It uses PD backrest for crazy fast backup and restores. This is very interesting and maybe the biggest pro. For example, like our production database, if we restore the production data with PG backrest, we can do it in 2.5 minutes. If we do it with a regular PG dump and PG restore, which is trying to do that in the most optimized way possible, that's anyway 20 minutes. So we're talking like an order of magnitude faster. And it's also faster for the backup part of it. It ships with native Prometheus Grafana integration. It also supports the database URL convention. You can tell that this is like coming from the Heroku world. So like, yes, we're like with people who understand database URLs. We don't want like host, username, port, password, right? We want the URLs. Very good. Cons, kind of non-aesthetic YAML. I mean, YAML, the YAML is something you have to get used to with Kubernetes. I think it took me 2 months of like until I kind of got out of that zone of just being annoyed all the time. And suddenly you kind of just don't care anymore. You're like, okay, I know, I can read it. How to use configure PG backrest can be non-obvious because it's not PG dump or PG restore that you might be used to. There's no community support here, so you're kind of on your own. There's a bit of dubious licensing going on. It's like they don't clearly state that like you're okay to use this. I have personally reached out to the founder of the company, and he's like, it's fine. If you're not Fortune 100, we're not going to go after you. It's fine. Use it. But it's a bit like they're like still like keeping that thing of like maybe they will go out after you. Like who knows? Documentation may be average. Some logs are not piped to standard out, so they're kind of not fully adhering to the principles you would expect from a Kubernetes stack. And there's no out-of-the-box read-only users or replica network services, which some other operators provide. With alternatives, I really want to highlight Cloud Native Postgres. They have an amazing community. They do a lot of these things that we have the cons on Crunchy. But it's like once you get that experience of using PG backrest, it's like you kind of want to use that, and Crunchy is the only one who does that. The other thing is when we tried this Cloud Native Postgres, we ran into some bugs. So it was kind of, we were time constrained. So our heart goes out to Cloud Native Postgres, and they seem really great and cool. There are also some other here, which I won't go into now. Redis operator, Spot-a-Home Redis operator, pros. It's the only open source operator supporting the Sentinel mode for high availability, which is the only sane way to go for a Rails app. Like there are two HA things in Redis. There is Sentinel and there is cluster. So Redis cluster is something which, for example, Sidekick doesn't support it. So it's more for if you're scaling out a massive cache layer, like want to horizontally scale a cache layer, then you would use something like Redis cluster. But if you just want your little Redis thing and you want like a master and a replica, then Sentinel is the way. It's still a bit complicated. So the cons here is over-reliance on Kubernetes stateful set for application, no built-in backup restore. It runs 3 Sentinels per Redis deployment instead of maybe 3 per cluster, which would have been maybe more easy to reason about, less resources running, etc. There's no built-in proxy for easy Redis URL integration. So Sentinel is something that is also you need to make the clients aware. So when you do your redis.new, you have to pass in the list of Sentinels if you want full failover thing to happen. The way that, like when you use Heroku Redis or Redis Labs, or Redis Enterprise, they call themselves these days, they will use some kind of proxy, which probably does the Sentinel thing for you, and then it just routes the traffic. So you don't really know. And the documentation is limited here. Alternatives, like Redis Enterprise Operator, that's money. And I wrote like in their chat, like I wrote a little simple question, and then they were like calling me every day for like a month. And I would like to be like, no, I'm not answering the phone. That wasn't what I wanted. Ops3 Redis, KubeDB. Like KubeDB comes up here a bit. That's an interesting one in a way. It's like also commercial thing, but it does all the different databases. So it could have been cool. It's like, single stop thing that can do all the databases, but didn't really give us that good of an impression, and we didn't want to also, we want to make this like an open source journey, like reclaim the stack, not pay the people or the service providers. Elasticsearch operator, that was a fairly simple choice. Elastic Cloud Kubernetes, this is made by the Elasticsearch guys, well documented. It makes it easy to deploy Kibana together with the cluster. Cons, no declarative backup restore. Like you're expected to do, use Kibana for the backup parts. Single node clusters end up in a yellow state. So by default, Elasticsearch is configured. This is also true for like dev machines, but it's configured so that everything should be at least replicated on one more shard. So this actually means that like if you're running Elasticsearch on your local machine, it's in yellow state, but you don't know. But if you run it in Kubernetes, then Argo CD certainly finds out and makes it like degraded, and you get alerts, and it's like, oh my God. So, but we kind of figured out that like the solution is actually just to run, at least 2 replicas for everything we do. Even if it's a staging server, everything is it just makes it so much nicer to administrate in the end, because you're not afraid to restart your nodes, etc. when you have replicas. Now, on to user experience. So we made a tool, we call it K for Kubernetes, or like OK. And you can study this list if you want in your own time. It's a single file Ruby script with 0 dependencies. It wraps kubectl, which is the CLI tool for Kubernetes, and it interfaces with the GitOps repo, which feels a bit like treating a Git repo on your hard drive as a database feels weird, but it's like what you do when you do GitOps, so it works. It does all the things we used to do with Heroku. Look at latency here, where again, let's put them side by side. So Heroku, just to run Heroku, like to get the command list, 3 seconds. On K, 0.1 seconds. Maybe it's because they're using JavaScript, I don't know. But if you would be using Ruby, maybe you can have it faster. Maybe that's why. Heroku console, 30 seconds, because they have to spawn like some EC2 instance, I guess, and whatever they do. We have 2 to 5 seconds. This is a game changer for, as a Rails developer, you can just like, yeah, I'm going to console in. It's going to be fun and fast. Heroku PSXX lets you go with bash into a running container. That's about 10 seconds. On Heroku, for us, it's like half a second. The deploys were, for us, about 5 minutes, to build the whole thing. When you git push to Heroku, we do it in 10 seconds. Asterisk, because we build the Docker images while we run the specs. So the build is already done. and then it's just like 10 seconds to actually just push the new image name into the GitOps repo, Argo CD, and etc. into the cluster. And then the pre-boot, which is like my most like, I don't get it. What are you doing, Heroku? Like 4 minutes, okay. That's what they do for 0 time deploys. On Kubernetes, you get rolling restarts, which is maybe like, it's basically the time it takes for your app to boot and like bind and get like a check that, okay, the HTTP is good. Now you can start switching over, which for our monolith is like 10 to 20 seconds, something like that. And what's also huge here is that if you don't make it, if you push a broken deploy that doesn't start, you will not switch the traffic, which like Heroku will gladly enter crashed state. Like it says there in the thing, right? It's like crash state, okay, let's switch the traffic. Like, I don't know why they think that's a good idea or why that's a thing, but that's what happens. Okay, kconfig, this is like Heroku config, but for us, there are some changes here in like how we think about the secrets management, in that we can have inherited secrets. So to kind of dry up the secrets, I guess. So the example we can give here is that we have these two ones, like New Relic license key and New Relic log. They come from the New Relic secret, which we can then share with all the apps because they all use the same license key. So we don't need to repeat that for every app. And if we have to change it, we can change it in one place. But then we also have the secret, which is by convention, it will have the same name as the application. That's where most of the things will go. So, but you can see here that we get a little annotation like where the secret actually comes from, but it lists all of them here. Also, we have built in grep as the last argument, because that's what I do all the time on Heroku. It's like Heroku config pipe grep. So we just built it in and we preserve the colors. Secrets edit is for mutating the secrets. When you run that, we open up your editor that you have configured. And you can just make your changes, save the file, and then it will sync to the GitOps. Logs, they will tail by default. That's pretty good. And you can also filter by type. So similar to Heroku, but a bit less typing, and it tails, which is what you want. You can also do logs : search, which opens up the Grafana UI for actually searching. It will have like a pre-baked filtering here for the application you want to search on, and then you can do your filtering. Dashboard opens up like something like Heroku metrics, both in Grafana, like request rate, latency, CPU usage, memory usage, etc. for an application. We also have some other dashboards, Postgres, and here we can rejoice in our 100% cache hit ratio because we have so much RAM we don't know what to do with. And we also have Redis dashboard. So these are coming from these operators. So that's nice. We also have a rollback. So you can roll back. You get a prompt of the last 15 releases. So you select the one you want, and it confirms that, OK, you want to roll back. OK, good, go. We also have alerting. So we have a Slack channel where we can get, if a pod isn't starting or if something goes wrong in the cluster, we get Slack alerts. This is part of this Kube Prometheus stack. You just configure Slack webhook. For all the authentication, from the command line tool to also like the web UIs, it's all authenticated with our like company Google sign-in, so OIDC. And then, the performance that we actually achieved in production, then this is the day after we went live, which is 2 weeks ago, approx. Monday is usually our busiest day. This is 7 in the morning to 7 in the afternoon, which is like peak time for us. So we went from 115 millisecond average latency to 82. That's a 33 millisecond reduction, or about 29%, which is massive. It's even better than the pitch I made for this talk, where I claimed it was 20%. But when looking at the numbers, I realized it's even better. So yeah, it's just very satisfying after all this work we put in to have this happen. Cost reduction, then we were approximately at like $200,000 per year on Heroku. We will be less than 20,000. You can do this in like maybe 5,000. If you want Heroku level performance, we could do it in maybe less than 5,000. But that's the fun part here. Is like we can use this overhead to actually like make the user experience fantastic. and just have fun also. It is fun. Like Daniel suspected this would be fun. Now it's really fun. Like yesterday we got like the new generations of CPUs were launched on Hetzner, so now we're like trying out, hey, what's the performance? Awesome. Okay. So maybe we'll get even better performance in a few days, who knows. Final words then. So like, are you sick of having your sessions expire and logging in to your tools every single day again and again and again? Are you like wondering what kind of world we live in where a reasonable company like New Relic are charging like $550 per user for their NPM? And would you rather sleep at night than like stay awake waiting for Heroku to fix their DNS upstream thing while getting no helpful support from their enterprise support whatsoever? Like you're getting better support from Hacker News at the time. Like they are within 1 hour they are like telling you you can do this to like get your app back to work, and like the Heroku enterprise support guy is like, no, you can't really do anything. Okay. Like, do you want to have a cheaper, faster, and better development platform or deployment platform? Then maybe you would like to join us on this journey and reclaim the stack. And when I say that, I'm hoping that actually other companies will go on this journey. And I think like, we spent these 6 months churning through some of these things. But I think for the next company, we can compress this. We can make it 2 months. For the next company, we can make it in 1 month. And we can collaborate, and we can share experiences, and we can figure out how to do this in like the best way possible, most stable way possible, and make it like a no-brainer to use your own stack. Hooray! And finally, thank you. And also, like, if you're interested to reclaim the stack, then check this QR code. There's a Google form for interest. I plan to maybe start like a Slack or a Discord or something where we can take the next step, because there's so much more to talk about, so much more to show. I wanted to make like a live demo of everything tonight, but it's just too much stuff, right? So you're welcome to join us.